So, chapter 3 I hope's kind of friendly. Let me just jump into it. So question 1, there's no calculus or algebra to do. It's just a matter of understanding what's being asked. And in this question, I give you the graph of a function, and I ask you to find intervals where the graph is increasing, decreasing, the coordinates of the maximums and the coordinates of the minimums. And to do this, I'm going to mark up my x-axis with the x-coordinate of any maximum or minimum, and with negative and positive infinity. I'm going to put negative infinity on the far left edge of my x-axis, positive infinity on the far right edge of my x-axis, and then the maximum point there of negative 1, 3, I'm going to put a negative 1 on my x-axis. The minimum point there of 0, 2, I'm going to put a 0 on the x-axis, and that maximum point I'm going to put a 1 on the x-axis. And then I'm going to create intervals that are implied by those numbers, all with round brackets for increasing and decreasing. So I'm going to do negative infinity to negative 1, negative 1 to 0, 0 to 1, and 1 to infinity. The region of the graph that corresponds to the first interval, negative infinity to negative 1, would be this interval, and put little up arrows on that interval because in that interval the graph is increasing. I'll just go write an INC here temporarily because I don't have that much room. In the next interval, the interval between negative 1 to 0, that corresponds to that portion of the graph, and the graph is decreasing because as I'm moving from left to right, the graph is getting lower, so I put little down arrows there. And now underneath the negative 1 to 0, I'm just going to write something that represents decreasing. The third interval, the interval from 0 to 1, relates to this portion of the graph, and as I'm moving from left to right, the graph is getting higher. The arrows that I'm drawing are getting higher, so that's an increasing interval. And then the last interval from 1 to infinity corresponds to this portion of the graph, and that's an interval where the graph is getting lower as I move from left to right, so that's a decreasing interval. When I go to answer 1A, the intervals where the graph is increasing, I'm going to put the two intervals where I have the blue increasing arrows, the interval from negative infinity to negative 1, all round brackets, the interval from 0 to 1, and I'm going to separate those with a union symbol. For 1B, to give me the intervals where the graph is decreasing, I'm going to put the interval negative 1 to 0 and positive 1 to infinity, and separate those with a union symbol. The way question C is added, the way question C is written, I probably would accept when you state the coordinates of the relative minimum, if you are maximum, if you just actually wrote the points. The point negative 1, 3 and positive 1, 3 are higher than any points close to them. Those are going to be relative maximums. So if you just wrote this for an answer to 1C, I'd absolutely live with it. It might be nice if you might have said this: there's a relative maximum of the y-coordinate of those points, y equal to 3, which occurs at the x-coordinate of those points. And for 1D, the point 0, 2 is the relative minimum. It's lower than any point that's kind of close to it. And for 1D, if you wrote just the point 0, 2 as the relative minimum, that would be okay. If you wanted to do something better, you can say there's a relative minimum of y equal to the y-coordinate of that point 2, which occurs at the x-coordinate of that point, which is 0. And that's all there is to do for problem 1. No algebra, no calculus, just knowing what the concepts mean. Questions 2 and 3, I'm going to probably use my calculator to help myself a little bit through the work, but not at the beginning. Question 2a wants me to take the derivative of this function, and that's a real easy derivative. The derivative of x to the fourth is 4x cubed. I'm going to bring down the minus sign and then do the derivative of 2x squared by multiplying the 2 by 2 and getting 4 and lowering the exponent to x to the first. So that would be the answer to 2a. That's the derivative of that function. Critical numbers are any values that make the derivative 0 or undefined, and the only critical numbers for this particular function I can get involve taking the function or derivative and setting it equal to 0. When I set this equal to 0, I'm going to solve by factoring. I'm going to pull out a common factor of 4x. When I pull out a common factor of 4x, I'm going to be left with an x squared minus 1. And then I'm going to factor the x squared minus 1 into x plus 1 times x minus 1. So I took the derivative, I completely factored it. Now I'm going to set each of the factors equal to 0. So I'm going to set 4x equal to 0. I'm going to set x plus 1 equal to 0. I'm going to set x minus 1 equal to 0. For the 4x equal to 0, I'm going to divide both sides by 4 and get x equal to 0. For the x plus 1 equal to 0, I'm going to minus 1 from both sides and get x equal to minus 1. And for the x minus 1, I'm going to add 1 to both sides and get x equal to positive 1. The answer I'm going to write for part B, the critical numbers are x equals 0, negative 1, and 1. To figure out where the graph is increasing and decreasing, I need a little bit of room. So let me go to the bottom of this sheet of paper and do the work for part kind of C and D. I'm going to create a number line that has negative infinity on the far left edge, positive infinity on the far right edge, and I'm going to take these critical values of negative 1, 0, and 1 and put them just kind of equally spaced to give myself some room to work. I'm going to create intervals that have all round parentheses that are implied here. First interval is going to be negative infinity to negative 1. The second interval is going to be negative 1 to 0. And then 0 to the 1 that I forgot to write. And then 1 to infinity. In each interval, I need to pick a number that's not an endpoint, but that's in the interval. For the first interval, I'm going to pick x equal negative 2. It's a number in that interval. In the middle interval, I'm going to pick x equals negative 1/2, or negative 0.5. 0.5 is a number in between negative 0 and 1, or negative 0.5 is in between negative 0 and 1. In the middle interval, or third interval, I'm going to pick x equal to positive 0.5. In the last interval, I'm going to check x equal to 2. What I'm going to do with those is plug those into the derivative. I'm going to find f prime of negative 2. I'm going to find f prime of negative 0.5. I'm going to find f prime of positive 0.5, and I'm going to find f prime of 2. One way to find f prime of negative 2 is to go to the function that's my derivative and say f prime of negative 2 is 4 times negative 2 cubed minus 4 times negative 2. That's going to equal to 4 times negative 8. Minus 4 times negative 2. That's going to be negative 32 plus 8. And that's going to give me positive 24. So one way to get a value for each one of these computations that I need to do is just to do it by hand. Another way to get a value is to cheat a little bit, and that's kind of what I'm going to prefer. What I'm going to do is I'm going to enter the function, not the derivative, but the function x up arrow 4 minus 2x squared on my calculator. I don't have a very good window. Let me go to Zoom Standard real quickly. That's not even so bad. So the graph of this function looks something like this. Once I have the function in y1, I could use my calculator to get these values. To get f prime of negative 2, using my calculator, I go second in calc, go down to option 6, the dy dx, hit enter, and then type -2, and it gives me, well, it gives me -24, which I should have gotten because -32 plus 8 is -24, and it doesn't get an exact answer. Sometimes it gets an answer that it feels is close enough, and it's a rounded, in some sense it's not an exact answer. I'm just going to round that -24.001 if I'm using my calculator to -24. I don't need super great precision when I'm doing this. I just need to get the right sign and not so much the right number. Let me do the same thing for -0.5 by going second calc, dy dx, and even though my calculator answer maybe isn't going to be perfect, exact, it's going to be close enough. And here I'm gonna round this to +1.5, I think. Even though maybe that's exactly what I get when I do it by hand. Maybe it isn't. It kind of doesn't matter as long as I get the right sign, whether this is positive or negative. The number that I write down here is not crucial. For the next one, I'm going to do 0.5. So second calc, dy dx, +0.5, and that gives me -1.5. And the last one, second calc, dy dx, type in 2 and hit enter, and I think it's going to be 24 again. So I've done all the computations I need to do. In this first interval, because I got a negative number, that's going to be an interval where the graph is decreasing. And so this is going to be part of my answer. This interval from -∞ to -1 is going to be part of my answer to D. In the next interval, I got a +1.5. Because I got a positive number, the graph is going to be increasing in that interval, and that interval from -1 to 0 is going to be part of my answer to part C. In the third interval, from 0 to 1, I got a -1.5. If I get a negative number, the graph is decreasing. If I get a positive number, the graph is increasing. So this third interval is going to be part of my answer to part D. I'm going to have two distinct intervals, so I'm going to separate them with a union symbol. And then the fourth interval from 1 to infinity, I got a +24. And when you get a positive, you get an increasing interval. And I'm going to put that increasing interval in my answer to part C, separate these with a union. So now I'm done with C and D, and I need to work on F and E. And I'm going to do this by making little arrows. The first interval is increasing. I'm going to make an increasing arrow. The middle second interval is increasing. I'm going to make an increasing arrow. The third interval is decreasing. I'm going to write a decreasing arrow. And the last interval is increasing. I'm going to write an increasing arrow. Immediately, I can tell that I have a relative minimum at x equal to -1. I have a relative maximum at x equal to 0. And I have a relative minimum at x equals to 1. So if I'm going to write a lazy answer, I know I have a relative minimum at -1 comma something. I don't know the comma something. I have a relative minimum at 1 comma something. I don't know the something. And I have a relative maximum at 0 comma something. I don't know the something. To get the something, or the y part, I need to plug the number into the original function. So for this x equal to 0, if I want to get the y coordinate of the maximum, I'm going to go to the original function and find f of 0. F of 0 is going to be 0 to the 4th minus 2 times 0 squared, and I'm pretty sure that that equals to 0. Another way to do that would have been to go to my main screen and did 0 up arrow 4 minus 2 times 0 squared to get that 0. Next computation I need is -1. I'm going to do f of -1. Using the original function, it's going to be -1 to the 4th minus 2 times -1 squared. I think that's -1, but I'm not sure. Let me do it here. -1 up arrow 4th minus 2 times -1 idiot squared comes out to -1. And for the last one, I'm going to do f of 1, which is positive 1 to the fourth minus 2 times positive 1 squared. And that's negative 1 again. So positive 1 up arrow fourth minus 2 times 1 squared, and I get negative 1 again. In some sense, I have a perfect answer. It's absolutely acceptable. I can maybe write my maximum and minimum answers better. So for the maximum, I could have said, I'd live with 0, 0, but I might like better if you'd said there's a relative maximum of the y-coordinate of that point, of y equal to 0, which occurs when x equal to 0. And similarly for this minimum, you can also say there's a relative minimum, I'm running out of room so I'm going to abbreviate, of the y-coordinate of those points, which occurs when x equal to negative 1 and positive 1. I don't know how readable these are, so 0, 0 would be a fine answer for the relative maximum, but you could say, and it might be better to say, there's a relative maximum of y equal to 0, which occurs when x equal to 0. And you can write those 2 points for the relative minimum, or if you want to be better, you can say there's a relative minimum of y equal to negative 1, which occurs when x equals negative 1 and positive 1. So that's kind of everything for number 2. Already 16 minutes into this, and we haven't gotten to the long problems yet. Number 3 wants me to do the same thing with this e function, so let me do the same thing. First, I'm going to find the derivative. The derivative of an e is super easy. I just take the derivative of the exponent. Exponent is x squared. The derivative of the exponent is 2x, and I multiply it by the original function. So the answer to part 3a, the derivative is 2x e to the x squared. To find the critical numbers for this derivative, I'm going to set the derivative equal to 0. The derivative is already factored, so I'm just going to separate the factors and set each of the factors equal to 0, which involves setting 2x equal to 0 and e to the x squared equal to 0. When you set 2x equal to 0, you divide by 2 and get x equal to 0. And the e to any power can never be 0, so that doesn't give a critical value. The only answer to 3b is x equal to 0. Now I'm going to try to figure out the answers to this by creating a number line that has negative and positive infinity at the edges, and the only critical number is 0 between those infinities. I'm going to create an interval from negative infinity to 0. I'm going to create an interval from 0 to infinity. And then I'm going to pick a number to test in each of the intervals. In the first interval, I'm going to check x equal to negative 1. It's in that interval, and it's not that hard to check. And in the second interval, I'm going to check x equal to 1. And by checking, I need to find f prime of negative 1 and f prime of 1. If the result is negative, the graph is decreasing. If the result is positive, the graph is increasing. For me, it's absolutely easiest to get these values on my calculator. Even though my calculator is going to give me decimals, I don't care, because it will give me something that's accurate enough to determine whether the graph is increasing or decreasing. So on my y1, I'm going to enter the function e to the x squared. And I don't really need to know what the graph looks like, but it can't hurt. Well, that looks like a parabola. That kind of really surprised me. Y equals e to the x squared. That's good. So now I'm going to go second calc, go down to option 6, and I'm going to do f prime of negative 1 by hitting enter on this number 6, typing negative 1, and my calculator gives me negative 0.54, negative 5.44, I guess. I do the same thing for the 1, second calc, option 6, enter, type in 1 and hit enter, and I get positive 5.44. Again, the number itself is kind of irrelevant. It's just the sign of the number that's important. So in the first interval, because I got a negative, the graph is decreasing. In the second interval, because my result is positive, the graph is increasing. So now I could write the answers to C and D. For D, the decreasing interval, is negative infinity to 0. For C, the increasing interval is 0 to infinity. And the graph goes like this. It decreases, and then it increases. So I have a relative minimum at x equal to 0, but there's going to be no relative maximum. So for the relative maximum, I'm going to write none. And for the relative minimum, I can say there's a relative minimum of y equal to some number, relative minimum, which occurs when x equals to 0, that's the x coordinate of the minimum point. To get the y value, I'm going to plug 0 in for the original function. I'm going to go f of 0 equals e to the 0 squared. That's going to give me e to the 0, because 0 squared is 0, and anything to the 0 power is 1. So I'm going to get a relative minimum of y equal to 1, which occurs when x equal to 0. And if you want it to, especially by the way the question is asked, you can just say the relative minimum is 0, 1, and I completely live with that. All right, that's everything for number 3. 4 is a friendly problem. 4 gives me a graph, and it just asks where the graph is concave upward, concave downward, and where the inflection point is. And it really nicely only gives me 1 point marked on the graph. And just like I did for increasing and decreasing, I'm going to mark up my graph. On the far left edge of the x-axis, I'm going to put negative infinity. On the far right edge of the x-axis, I'm going to put positive infinity. And between the infinities, I'm going to put the number 3, which is the x-coordinate of this point. And I'm going to create the intervals from negative infinity to positive 3, the interval from 3 to infinity. The first interval, the graph is kind of bent that way, and that's a concave down. So this first interval is going to be in the concave down or concave downward, depending on which word you prefer to use. I usually use down, but in the question I say downward. So you can say it's concave downward between negative infinity and 3. The next interval, the graph is kind of cupped up, and that's what a concave up interval looks like. So I'm going to say it's concave upward or concave up in the interval from 3 to infinity. And the point where the graph changes concavity is called an inflection point. That's the point 3, negative 18. And the nice thing about inflection points, we don't say like there's an inflection point of y equal to negative 18, which occurs at x equal to 3. That's just not done for inflection points. For inflection points, you usually just give the whole point. So that's everything for question 4. We just have a little bit more to go. So question 5 is the last part on this review. It asks me to find the intervals where the graph is concave up, concave down, and wants me to find the inflection points. To do this, I need to get the second derivative, because where the second derivative is equal to 0 is going to be important. So the original function is 1/3 x cubed minus 3x squared, and I'm going to do 2 derivatives. For the first derivative, I'm going to take the exponent of 3, multiply it by 1/3, lower that to 2, and the 3x squared has a derivative of 6x. These 3's cancel, and the first derivative becomes f prime of x equals x squared minus 6x. Now I'm going to do a second derivative, f double prime of x equals 2x minus 6. So I have the second derivative of 2x minus 6. I'm going to get a critical value by setting that second derivative equal to 0. So I'm going to set 2x minus 6 equal to 0. I'm going to add 6 to both sides and get 2x equals to 6. And then I'm going to divide by 2. That's going to give me x equal to 3. I'm going to put that number on a number line that also has negative and positive infinity. So I'm going to do negative infinity, positive infinity, positive 3. Just like for increasing and decreasing, I'm going to create intervals. The intervals I'm going to create are negative infinity to 3, 3 to infinity. And then I'm going to pick a number to plug into the second derivative. In the first interval, I'm going to plug in 0 because it's in that interval. It's easy to do algebra with. In the second interval, I'm going to plug in 4. It's in that interval. It's smallish. For each one of these, I need to plug the number into the second derivative, and my calculator on the dy dx can't do that. That plugs number into the first derivative. So I'm going to do these by hand. I'm going to do f double prime of 0, which is going to be 2 times 0 minus 6. And that comes out to 0 minus 6, which is negative 6. In the next interval, I'm going to plug 4 into that and get f double prime of 4, which is 2 times 4 minus 6. That's 8 minus 6, which is 2. If I get a negative in that interval, the graph is concave down. If I get a positive, the graph is concave up or upward. So in the first interval, because I got a negative, I'll say it's concave downward. It doesn't say whether it's increasing or decreasing. It means it's just cupped that way. And in the second interval, I got a positive, so the graph is concave upward. Again, it doesn't say whether it's increasing or decreasing. It just says how it's cupped. So the answer to part A, it's concave up, or you could use upward, from 3 to infinity. And it's concave down, or you can say downward, from negative infinity to 3. And this 3 is the x value of an inflection point. Because the graph changes concavity on either side of x equal to 3, I have an inflection point. And I know half of the inflection point, its x coordinate is 3. I don't need to say anything fancy with inflection points by separating the x's and the y's, but I do need to get the y coordinate. To get the y coordinate of the inflection point, I'm going to go f of 3 is 1/3 times 3 cubed minus 3 times 3 squared. I don't really care to do that by hand this morning, so let me do this on my calculator. Do parentheses 1 divided by 3 for the 1/3, and then times 3 cubed minus 3 times 3 squared, and that's going to give me the y coordinate of negative 18. So I'm going to say the inflection point, the answer to part B, is a point 3, negative 18. That's everything I need for number 5. That's everything we need for this half of the video. The next half of the practice test is kind of a repeat of this, but then on top of this we do graphs and find some intercepts.